Last quest, you guys learned some angle pairs that get formed when we have two lines that we want to check to see if they're parallel or not. When we introduce a transversal or a third line that intersects the two lines, it creates 8 angle pairs. Okay, we have corresponding angles, alternate interior, alternate exterior, same side interior, which are also known as consecutive interior angles. We're going to use those pairs to help us argue if objects are parallel or not. So like in this picture that you're looking at right here, we got this kind of cool city light picture, and we got two light beams just shooting straight up into the sky. So let's use math to prove or disprove that these lines are truly parallel or not. Because when I look at them, they look like they are. So what I'm going to do, since I want to check these two lights out, I'm going to save my picture. So I'm going to right click, or you hold down on your tablet on this picture, for example, and I'm going to save the image. Okay. So once you have your picture file saved, then we can go into GeoGebra. I don't need anything but a white screen, so I'm just going to get rid of those. And now let's insert that picture. So I'm going to go to my text toolbox here, the one with the ABC, and I'm going to click the down arrow. And there's an insert image tool here. So remember, where you click is going to be the bottom left corner of your picture. So I always click down here in the bottom left. And I got to go find this picture that I have, which I believe is called Parallel Lights. Okay, there's my picture, and I click Open. So now I got that picture in my GeoGebra. Remember, if you have a picture that's too big or too small and you want to change the size, what we have to do is grab our new point tool and put 2 points down on our GeoGebra window here. And then I need to define the corners of this picture by these 2 points A and B. So to do that, anytime you want to change the properties of an object, you just right click it or hold down on it on your tablet and go to Object Properties, go to Position, and you can see there's 3 out of the 4 corners we can define to actual points. So this bottom left corner, I'm going to make it A. This bottom right corner, I'm going to make it B. And now, when I exit out of there, this picture is defined by wherever these points are. So I can make it bigger or smaller, whatever, to make it look nice. Okay, so let's check to see if these two lights are parallel or not. So what I'm going to do is grab my line tool. You can use a segment tool, whatever, but I'm going to use my line tool. I'm going to make this stand out a little bit. So maybe, I think red will stand out. I'm going to make my lines pretty thick. Now there is a little bit of wiggle room in here, and you'll see what I mean. I mean, where do we put the line? Because the actual light beam is relatively thick, right? So we could be off a little bit here. When we do this argument, we check angle measure. Let's call it we'll measure within 1/10 of a degree. So if the angles, say, need to be like alternate interior angles are congruent when lines are parallel, we just know when we measure those angles that when we check to the 10th, that they're going to have the same value. They might be off past the 10th, but for our accuracy, we'll go to the 10th because there is a little bit of wiggle room, right? Like I could still be, on the light beam by kind of changing these up a little bit. Okay, so those seem relatively representative of my lights now. So here are my two lines, my two lights that I want to check to see if they're parallel. So we have to add that third line, that transversal. Okay, so maybe I'll do that in yellow. So it doesn't matter at all how our transversal intersects our lines. It's just that we want to find angle value. So this, no matter what we do, is going to just change the angles, but we're looking for congruent angles, meaning the same measure. Okay, so what we need to do is put some points on the intersections so that we can have some vertices to click on for our angles. So now that I have my intersection points here, we can see, I hope, that we have 1 angle, 2, 3, 4, 5, 6, 7, 8 angles here, right? So now to check to see if these are parallel or not, we just have to grab one of those angle pairs. And remember, we have corresponding angles, so angles that are in the same positions on both lines in the transversal. We have the alternate interior angles, so angles that are on opposite sides of the transversal and in between the lines. Alternate exterior angles, angles that are on alternating sides of the transversal but on the outside. And we have same side interior angles, two angles that are on the inside on the same side. Every single angle pair except for the same side interior angles have to be congruent if these lines are parallel. The same side interior angles are just going to be supplementary, and we'll prove that later. When we start talking a little proof and I start putting those in there, I'll ask you why these are supplementary, okay, and see if we can argue why they would be. So all we have to do is check one angle pair. I'm going to do corresponding angles, for example. So my eye right now, just looking at this picture, there's lots of corresponding angle pairs in here. We just have to pick one and see if they're congruent or not. So maybe like this bottom left side of the line, this angle right here, bottom of the transversal left side of my red parallel line, that angle, I'm going to measure that. Remember, to measure an angle, we have to click 3 points to measure that angle, and they have to be in a counterclockwise, or excuse me, a clockwise direction. So I'm going to click on point G, then the vertex, and now it's just waiting for me to put that third point down right here. So my angle that I just measured is right here in my algebra window, 62.32. So we're going to just round to the 10th, call it 62.3. Alright, so now I'm going to check its corresponding angle here, which is this one right here. Okay, so I'm going to click on this point, and this point, and we get 62.14. So if we round to the 10th, these two angles are not the same. So remember, there is a little bit of wiggle room here, but I don't think, actually, now that I moved that point around there, that still looks good to me. So I think that just being off a little bit, then these two lines now, and that looks pretty good. I think that looks better in the way that I had it. Those are really representative of the lights, and we can see that they're the exact same angle. So these two lights are truly parallel. Okay, I'm going to do a new window here and just say, I'm going to put some lines here that look like they're parallel, but they're not. Maybe like here. Okay, those to me look like they could be parallel, but I don't think they are. So those are going to be my two lines. Maybe I'll make it, I'm not sure if that'll stand out in your video, I'll make them red. Okay, so let's see if these two lines are parallel. So we need a transversal, which I'll make in this case green now. I'm just going to intersect my lines with my transversal, and I need those intersection points here and here. Okay, so now I'm going to measure a different angle pair. Maybe I'll measure alternate exterior angles. So I'm going to measure, say, this angle here happens to be 109.94. And now I'm going to measure its alternate exterior angle, which is right here, and we get 109.46. And there's no finagling here. I just happen to have lines to check if they're parallel, so that I don't need to adjust it to make them parallel. If you were just asked, are these two lines parallel? Right now, if we're going to go off the 10th, they're pretty close to parallel, but they're really not. They're off of a half of a degree. So because alternate exterior angles are not congruent, then these lines are not parallel. Alright, good luck with the assignment, guys.